How does the resistance of the SEI membrane, denoted as RCI, contribute to the overall impedance response, and what role does it play in the behavior of the electrode during cycling? What does the charge transfer resistance RCT represent in EIS analysis, and how does it provide insight into the kinetics of the electrode reaction? How does the frequency omega factor into the impedance data, and why is it important to measure the system's response at different frequencies? In this context, what is the significance of the Warburg coefficient sigma, and how does it relate to the ion diffusion process within the electrode and electrolyte? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is the sodium-ion diffusion coefficient DNA, and how does it influence the charge and discharge rates of sodium-ion batteries? How do parameters like the gas constant R, absolute temperature T, surface area A, and the number of electrons transferred per molecule of oxidation N influence the electrochemical reaction and its rate? How is the Faraday constant F used to relate the charge transfer process to the number of moles of electrons involved, and what role does it play in quantifying the current density during the electrochemical process? What is the significance of the sodium-ion concentration CNA in the electrolyte, and how does it affect the system's performance, especially in terms of ion transport and battery capacity? How does the steady-state polarization curve provide insight into the relationship between current density and overpotential, and what can it reveal about the rate-limiting step in the electrode reaction? How can the kinetic parameters of the rate control step be determined from the steady-state polarization curve, and what are their implications for understanding the reaction dynamics? How can the EIS results, combined with the steady-state polarization curve, be used to calculate the mobility of sodium ions DNA in the system, and why is this important for optimizing the performance of sodium-ion batteries? What does the mobility of Na ions tell us about the efficiency of ion transport within the electrode and electrolyte, and how does it affect the overall charge/discharge rates of the battery? How can these calculations and insights be used to improve the design and selection of materials for better performance in sodium-ion batteries or other energy storage systems? What is the role of I0, the initial state current, in determining the starting point for electrochemical measurements, and how does it influence the initial electrochemical response of the system? How does ISS, the steady-state current, reflect the long-term behavior of the electrochemical system, and why is it important for understanding the overall performance of the electrode?